The cool evening breeze from the southeast creates these clouds on Table Mountain, South Africa's most famous natural monument. The city of Cape Town at its base is not only a popular tourist destination, but has also become a gathering place of scientists from all over the world, heading for the southernmost continent, Antarctica, for climate research. It is past midnight at Cape Town International Airport. The last pieces of cargo are being loaded on an Ilyushin 76 aircraft. With about 60 climate researchers on board, the airlifter is heading south. At the same time, in the South Atlantic, the icebreaker Polarstern has reached the Antarctic Ocean that surrounds the continent, carrying hundreds of tons of additional equipment for the research bases. On its way, the scientists on board of the ship are constantly collecting data and exploring the unknown marine life of the depths of the Southern Ocean. Their goal is to better understand its ecosystem and its impact on the world's climate. When temperatures rise in the polar summer, the barrier ice that shields the continent in winter breaks up, and research vessels are able to enter these tricky waters. Scores of icebergs are drifting north, while penguins and other species are taking advantage of the milder summer months to prosper and to procreate. It was a 6-hour flight from Cape Town to this airstrip on the glaciers of Antarctica, 4,100 kilometers southwest of Cape Town. The passengers had boarded the plane at plus 30 degrees Celsius. On the ice, temperature has dropped to minus 30 degrees. Every piece of equipment and food, the station itself and the scientists themselves all have to be brought to Antarctica. There are no well-functioning transport routes here as in Central Europe, where you can jump on a plane and arrive 2 hours later, wherever you want to be. Here it is an enormous logistical challenge. At the airstrip near the Russian-based Novolazarevskaya, the pilots of smaller cargo planes are struggling with the manual pumps to refill their aircraft. They have just arrived from Europe via South America, hopping from base to base. They will shuttle the researchers to other stations like the European outpost Konen or the permanent German base Neumayer. With their limited capacity, it takes the aircraft several flights to bring all personnel and equipment to their destination.
You have to fly here at least as carefully as at home. Even more so, since moving in this vast territory, one little problem can cause an avalanche of trouble that you want to avoid. That is why we are probably even more careful than usual.
Wary of the weather, Martin Hinterwaldner is taking off with the first load of researchers and equipment. 30 countries are running a total of about 65 research stations in Antarctica. So in the polar summer, between December and February, the number of people living and working on the continent rises to more than 4,000 men and women. The Russian-based Novolazarevskaya has become the gateway for researchers flying in from South Africa. From there, it is another 740 kilometers to the permanent German base Neumayer, and 540 kilometers to the summer station Konen, where climate researchers from Europe want to extract one of several ice cores from the glaciers of the continent. At Novolazarevskaya, Hubertus Fischer and his team are exploring the Russian base until the aircraft return. Built on a mountaintop and surrounded by glaciers, it resembles more a museum of ancient Soviet machinery than a research base. But times are changing, and the crew at Novo, as it is called, has started a big cleanup, as it has become an important hub for scientists to venture out further on the continent. At the base, Frank Wilhelms tries to use the waiting period at Novo to establish an internet connection with a satellite dish. The members of his team are from half a dozen countries, including Iceland, Sweden and Poland. They all want to send messages back home that they have arrived safely in Antarctica. But the high-tech gear does not seem to function at first. It takes the geophysicists some time to figure it out. Meanwhile, there is bad news coming in from Neumeier Station. The two shuttle aircraft were able to land there safely, but due to drifting snow, they are unable to go back to the Russian base until weather conditions have improved. Hubertus Fischer and his ice drilling team are trapped at Novo. Frank Wilhelms takes the news with a shrug and a smile, but he also knows that every day of delay threatens their timetable for the ice drilling high up on the inland glacier.
For
the time being, we're still on our original schedule. Originally, we had planned a transport flight to Neumeier Station today for the rest of the team, but this has been cancelled. At Conan Station as well, we do not yet have a delay, but it's a problem that there are now only 4 of our team there, and one of them, Kurt, has some problems with the altitude, so they cannot get as much work done as they want to. The scientists try to make the best of it. Some of them are jet-lagged and still have to adapt to the 24 hours of daylight in the polar summer that confuses their biorhythm. Others, like Hubertus Fischer, are making preparations for their research program. One needs to use the time meaningfully. At home, there is often no time to focus on one thing only. There was so much to do for the preparation of this expedition, so this kind of work always had to wait. It is another 2 days before the shuttle aircraft can pick them up. Hubertus Fischer and Frank Wilhelms are headed for the inland base Conan to continue their project within the European Ice Core drilling project, EPICA. Others are flying to Neumeier Station at the Antarctic coast, to Atka Bay, with its millions of emperor penguins. These cute animals do not get much scientific attention these days. Researchers are focusing almost exclusively on projects that shall help to assemble pieces of the puzzle that explain the changes in the world's climate. On the 200-meter thick shelf ice floating on the sea, Neumeier Station is buried in the ice in 2 80-meter-long steel tunnels. Now the crew of 9 men and women that has spent the winter months there gets lots of company. In winter times, with temperatures below -40 degrees Celsius and scarce daylight, the crew was only able to do minor maintenance work to guarantee continuous scientific measurements. With the arrival of the summer team from Novolazarevskaya, the station is buzzing with activity. A ramp for vehicles down into the underground station has been covered with snow and ice throughout the winter and needs to be cleared. Meanwhile, the winter crew is happy that the 9 winter months of almost complete isolation are over.
It is such a pleasure to see new faces and listen to their stories. Everything has to be organized anew, and that is a lot of fun. So now the experience of nature is of a bit less significance to me, as the life here on Neumeier resembles more a youth hostel or a student's dormitory. That is really nice.
The transition from sunshine to storm sometimes only takes a few minutes. Weather dictates the rhythm of life on every station in Antarctica. But 12 meters beneath the surface of the shelf ice, little can be felt of nature's wrath above. The new arrivals have to get used to living in a windowless home beneath the surface of the ice, a mixture of submarine and prison. Sometimes the crew is unable to leave its tunnel for days, especially in winter. Now, in summer, it gets crowded as the crew members have to share their little cabins with the newcomers, after months of an almost hermetic life in the ice. Station Chief Isabella Eli is preparing to hand over her duties to the next winter crew. Inventory of food, spare parts and fuel takes her several days, but is crucial for the next hibernation period. Antarctica is a continent of extremes. Almost completely secluded from the rest of the world by ocean currents, it has developed a unique ecosystem. At the same time, it is harboring in its ice a climatic archive due to its extreme temperatures. An archive that tells scientists about the history of the Earth's climate and the reasons for its changes. As soon as the storm has calmed down, the scientific work has top priority. There are several semi-automatic laboratories on the base, but weather balloons still have to be launched by hand almost every day. High up in the atmosphere, the instruments are measuring temperature, humidity, and air pressure, and send the data back to the station. Only these long-term measurements can show significant changes in the atmosphere. From high above the ice, radar measurements from airplanes shall help to answer one of the most controversially discussed questions in climate research. Are the glaciers of Antarctica losing mass due to global warming? And if they are, how much? In an international flight campaign, researchers like Daniel Steinhager are systematically crisscrossing specific areas of the continent to measure the thickness of the ice shield and its changes, and to compare it with future data from satellites.
With our flights along the outflowing glaciers, we want to record the thickness of the ice. Together with the analysis of satellite pictures, from which we obtain the velocity of the surface of the ice, we want to determine the net outflow of the ice from the glaciers.
Meanwhile, the second aircraft is shuttling back and forth between Neumayer and Conan Station. The European base Conan is located 750 kilometers south of Neumayer, at an altitude of almost 3,000 meters in the middle of the Antarctic ice shield. Some members of the team had problems adapting to the altitude and have to be flown out to Neumayer base. Until a land convoy reaches the station later in the season, the airplanes are the only way in and out. Conan Base has been set up for the sole purpose of drilling an ice core from the glacier 3 kilometers down to the bedrock of the continent. In a trench in the ice next to the station, the drilling tower has been set up 10 meters below the surface to better protect against the rigors of nature. In the previous summer season, the drilling crew was able to reach a depth of 450 meters. This summer, they have to reach 1,500 meters. It is the first drill of the season, and Frank Wilhelms is nervous. There have been several projects before where equipment malfunctioned or drill heads were lost completely. Such incidents did not only ruin carefully planned expeditions, but also scientific careers. This time as well, something seems to go wrong. The drill head was not able to cut as deep into the ice as planned.
These are simply compressed chips of ice. Usually you do not see what causes the problem down below, but when you extract the driller carefully, sometimes you can see. These chips have blocked the outflow channel. They were supposed to be cut here and move up the channel.
For the time being, Frank Wilhelms and his colleagues do not have a clue how to solve the problem. Also, the flight crew at Neumayer has troubles. The instruments for the left engine showed abnormal parameters in flight. We returned as a precaution. Tomorrow we will start looking for the cause of the problem. Maybe there was some ice which melted due to the heat of the engine, but that's just a guess. The next morning, Dirk Hasselbring and his colleague Siegfried Jutt begin their investigation. In the air, the airplane will be able to continue its journey with one engine. But in Antarctica, taking such risks would be irresponsible, as there are only a few airstrips around and landing in the middle of nowhere could have fatal consequences. Until the problem is solved, the plane is not allowed to depart.
There are
checklists that we are following now with a kind of search system that has been prescribed by the manufacturer. We are switching out parts and testing them, and in this way we are trying to identify the source of the problem. While Dirk Hasselbring and his colleague continue their examination, the icebreaker Polarstern has reached the edge of the shelf ice, a dozen kilometers from the base. With hundreds of tons of food, equipment and fuel on board, the research vessel is a lifeline for both stations Neumayer and Konen. Unloading the cargo and loading the icebreaker with the return freight of waste material and last year's ice cores takes 3 full days. Tracked vehicles tow the sledges loaded with the containers away from the edge of the shelf ice to the station. In the process, the vehicles consume about 20 liters of fuel per kilometer. At Neumayer, the technicians of the grounded plane have given up searching for the cause of the engine malfunction. They have communicated by email and phone with colleagues in Germany and experts at the manufacturer. Finally, they decide to install a spare engine that has fortunately been stored at the base. The icebreaker did not bring any other spare parts for the airplanes this year. Changing an entire engine at temperatures of -20 degrees is no walk in the park, even when the sun is shining. It takes the 2 technicians several days to attach every tube and every sensor before a series of tests on the ground is started.
Now we have to do the fine-tuning with lots of trials, adjustments and so on.
The engine seems to work, but before the pilots can start any flight tests, weather conditions worsen and force the planes to stay on the ground. "750 kilometers inland, the ice drilling team at Konen Base has not made much progress. Several other attempts with minor adjustments to the drill head failed as well. This time also, Frank Wilhelms is not pleased with the result.
This is some sort of dirt that has accumulated in the drilling fluid.
The ice core itself has only a length of 15 centimeters, another failure. Drilling in the ice is so difficult because it is not an established technology. We have had ice core drilling projects since the 1960s, but only for scientific purposes. So there is no industrial sector like in the oil business that develops drilling technologies. It has all been developed in-house. Ice changes its mechanical characteristics constantly, so one has to make adjustments all the time, and that is why it gets so complicated. But the results are worth the effort. With every piece of ice or sample of snow, researchers like Hubertus Fischer are able to put another piece of the puzzle in place that can show them the processes in the world's present and past climate. Using this data later in computer models allows them to calculate where our climate is heading to and mankind's responsibility for it. collecting the pieces of the climate puzzle can be a frustrating experience. After several failed attempts, Frank Wilhelms and his drill team at Conan are tired and hungry. So far, the minor adjustments to the drill head have not led to much progress. Finally, they decide to widen the outflow channels of the drill head, which is risky as there are only 2 such heads on the station. Then the drill is sent down again. It takes almost an hour for it to reach the bottom of the hole, and the same amount of time to haul it back to the surface. The team is waiting impatiently. This time, the drill was a success. The ice core has a length of more than 1 meter and 40 centimeters. Cut in pieces and carefully wrapped, the ice cores are going to be sent to laboratories around the world, where the tiny bubbles inside the ice will be analyzed, as they contain samples of the Earth's atmosphere some 10,000 years ago, as pieces of the climate puzzle. We want to understand the climatic processes and the mechanisms that trigger changes. If mankind artificially turns little screws in these mechanisms, this can trigger such a change. Or do we rather experience continuous changes like in the last 100 years, that mankind could more easily adapt to than to fast climatic changes?
Zu kompensieren sind, als es sehr schnelle Klimaschwankungen sind.
At Neumayer, the installation of the new engine was successful, but the pilots first have to conduct a series of test flights before they can continue with their scientific mission.
During our test flights, we will check different parameters of the engine and compare it with the other one. We will cut off the engine, restart it in flight, and check its conduct during descent and at touch and go at Neumayer. Then we will circle the aerodrome and touch down, if everything has worked out.
As soon as the test flight is completed, it will also be the task of the aircraft to fly the precious ice cores out. And with them, a climate archive in bubbles of compressed air. It will allow scientists to measure the concentration of carbon dioxide and other greenhouse gases 160,000 years back in time. Gases that not only threaten to ruin the ecosystem of Antarctica, but also the future of mankind.
We know, for example, that over the last 800,000 years, CO2 concentrations were never as high as today, just by natural reasons. And in addition, those ice cores are also very important validation tools, validation data for climate models, because only if those climate models are able to reconstruct or hindcast the temperature variations in the past, which we can really measure on climate archives, then they are also reliable to do prognostics into the future.
We know about very abrupt swings in climate that are recorded in the ice cores, and that show us that the system is very non-linear, or what we call it has tipping points. This is a bit like in a rowing boat. If you rock it from one side to the other, not too much happens, but if you lean over too much, it will suddenly flip over. And the climate system has such tipping points, for example, in the ocean circulation. We know from the history of the last 100,000 years that at least 20 times there were sudden flips in the ocean currents in the Atlantic, for example. With global warming, we are in many cases moving towards such tipping points where we expect sudden, often irreversible and very fundamental changes in the way our climate system works.
There will be a warming, and it's a matter, will the warming be 2 degrees or 6 degrees by 2100? But there will be warming. And every year which passes, we will have a higher load of CO2, and this will have a long impact on our climate. So every year we don't do anything, we lose, and it will become more and more difficult to get this problem into grips.